Hello everyone, welcome back to Math with Allison. Today we are continuing our series with derivatives, but we're going to be doing an exam. So let's go ahead and look at it here. This is from 2014. This is from a professor that I have worked with. She is super amazing and she is letting me do this exam through YouTube. So the PDF is linked down below if you want to try the exam out before we go through it, or if you want to work on it at the same time. So go ahead and do what you want with that. Otherwise, we're just going to go through it. This is released as practice for the actual upcoming exam. And also, just side note, the derivative unit is split into two different exams. So this would be the first half of material. And then we'll do some exams on the second half of material later on. So let's just go ahead and dive into it. We can see the point distribution here. So there's 6 total questions, and we can see how much each question is worth. It's sometimes nice to go through and see which ones are weighted differently. So let's go ahead and do the first problem here. So in the box below, state the limit definition of a derivative f prime x. So if we remember the limit definition, this is going to be the limit as h approaches 0 of f of x plus h minus the original function f of x, and all of this is going to be divided by h. So now in part B, we want to go ahead and use this limit definition in order to show that the first derivative of 3x squared plus 1 is equal to 6x. So let's go ahead and use that. So our actual function f of x is going to be what we're taking the derivative of. And so that's going to be 3x squared plus 1. Now let's go ahead and find what f of x plus h is. Remember, we're just changing our input. So everywhere we see an x, we're going to replace that with x plus h. So this becomes 3 quantity x plus h squared plus 1. If we wanted, what we could do is simplify this out a little bit. So first we can square this x plus h squared. Remember, this is going to be x plus h times x plus h. And so when we do this, we have to FOIL it out, make sure we distribute it everywhere. And we end up getting 3x squared plus 2hx plus h squared plus 1. So now we can go ahead and distribute that 3 all the way across, and we get 3x squared plus 6hx. So now that we have that simplified out, we can go ahead and plug it into our limit definition. So we have the limit as h approaches 0. And now we can put in our simplified form of f of x plus h. And so here we get 3x squared. And now we need to subtract the original function. And so we're going to subtract this whole thing over here. So here I put the function in parentheses or brackets because we have to remember to distribute that minus sign to everything in there. So I'm going to do that. Alrighty, so here we want to go ahead and look for terms that are going to cancel out. So I can see this 3x squared minus 3x squared cancels, and the 1 minus 1. So I'll go ahead and rewrite that. So here, remember, the issue is that h in the denominator. We want to somehow get rid of that h. And we can do that in this case by factoring out an h from the numerator and canceling those out. So now we got rid of that h in the denominator. Remember, that's the goal of simplifying the limit definition of a derivative. We get rid of that h. So now that I did, I can go ahead and plug in the actual limit. So we have h is approaching 0, and I'm going to replace that everywhere I see an h. And here we got that the derivative is equal to 6x. And so if we go back to the original problem, we definitely show that the derivative of it is equal to 6x. Alrighty, number 2, we are asked to find the derivative of the following function. So let's just go through part by part. So part A, we want to find the derivative of f of x. So I'll write that out. F prime of x is equal to, and it looks like this is going to be a polynomial, so we can use power rule. So first, I'm going to bring down the exponent, and that 3 is a scalar multiple, so it just hangs out. And then we subtract 1 from the original exponent. So 4 minus 1 is equal to 3. The derivative of just x is equal to 1, so this becomes minus 2. And now the derivative of 5, the derivative of a constant is always equal to 0. And so here, if we want to simplify that out a little bit, we can multiply 3 times 4, which is 12x cubed minus 2. And that's our derivative. Now for part B, it looks like we're going to want to use quotient rule. So we have the numerator is 2 minus 5x squared, and the denominator is secant. I'm going to go ahead and set that up. So here for f prime, we are taking the derivative of a polynomial, so this becomes a negative 10x. Now for g prime, we have to remember that the derivative of secant is going to be secant x tangent x. You can always just whip out quotient rule if you want. You can rewrite secant of x of 1 over cosine, and you can go ahead and apply quotient rule and you'd get the same outcome. So if you forget the derivative of secant, you can always do that. So now when we apply quotient rule, we start at the bottom and work our way to the top. So here I'll write out, since we're working with y prime is equal to, and I'll multiply those two together. So I get 10x times secant of x. And remember, now we have to subtract, and we start at the top, work our way to the bottom. So here I get 2 minus 5x squared times secant tangent. And all of this is going to be divided by the denominator squared. So secant of x. So here is where I suggest you stop. All that this problem is asking us to do is to find the derivative. It is not telling us to simplify. So it's going to save time if we just write it out, the first derivative, and leave it as is. Of course, this depends on the professor. If this question did say to simplify, you would have to continue simplifying. But in our case, it doesn't, so I'm just going to leave it as it is. Alrighty, so now for part C, we want to find the derivative of g of x. I'm going to go ahead and use product rule right here. So I have my first is x plus 3x squared, and my second is natural log of x. Whenever we notice that there's multiple x's, so multiple x's here, we have an x here, we're typically going to apply product rule. So let me go ahead and set that up. Alrighty, so if we take the derivative of f, we get 1 plus 6x. And now we have to remember that the derivative of natural log x is equal to 1 over x. So now when we do product rule, we don't necessarily have to worry about the order, but I suggest keeping it the same as quotient rule, so we just always remember that. So here g prime x is equal to 1 plus 6x times the natural log of x. And now we get to add the other cross multiple. So here we get x plus 3x squared times 1 over x. Again, I suggest stopping here. There's always room for error if we keep simplifying, and it's just asking for the derivative. And there I have the derivative. Okay, so now for part D, notice here that we do have a fraction. We could do quotient rule, or we could go ahead and rewrite this. So I have t minus 3t to the negative 2. So I can bring that up using exponent rules, plus e to the 2t. From here, we can take the derivative. So s prime of t is equal to, derivative of t is just going to be 1. And now we can go ahead and apply power rule. So I'm going to bring that exponent down, and then I'm going to subtract 1, so that becomes negative 3. And now the derivative, if we remember the e rule, first what we do is we drop it down, and then we multiply by the derivative of the exponent. So the derivative of 2t is just 2. So we could rewrite that as 2e to the 2t. If you wanted to simplify it out a little bit, you could. So this becomes 1 plus 6 over t cubed plus 2e to the 2t. But you're also perfectly fine stopping right here because this is by definition the derivative. Alrighty, problem 3, we are asked to find more derivatives. So let's go ahead and try part A. We have r of theta is equal to sine of tangent of theta. If we get confused on when we need to apply product rule and chain rule, just look for how many variables we have. In our case, we only have one variable. So if there's one variable, it's going to be chain rule. So the outside is going to be sine, and the inside is going to be tangent of theta. So let me go ahead and set that up. So the derivative of tangent is going to be secant squared theta. And now the derivative of sine is going to be cosine of u. So now when we find the actual derivative, r prime of theta, we take u prime, so secant squared of theta, and we multiply that by g prime of u. But we're going to replace u back in. I know that u is equal to tangent of theta. And once again, we can just stop right there. It's not asking us to simplify. I found the derivative. I'm good to go. Alrighty, so again, let's go ahead and apply chain rule. So the outside is going to be to the power of 5. And right now, the inside is going to be the sine of 2x to the 4th. So now we want to find the derivative of u, but it looks like, again, we're going to have to use the chain rule because now our inside is going to be 2x to the 4th and our other outside is going to be cosine. So if we wanted, we could set up another chain rule where we have u is equal to 2x to the 4th and g of u is equal to cosine of u. So if we find u prime, we end up getting 8x to the power of 3, and then that g prime of u, we have negative sign of u. So when we fill that in, we multiply 8x to the power of 3 times negative sign, and I replace u back in, so I get 2x to the power of 4. Now for g prime of u, that's just going to be a nice power rule, so I get 5u to the power of 4. So here, remember when we want to find the actual derivative, so y prime, we take our u prime, and I can go ahead and move that negative to the outside. So negative 8x cubed times sine of 2x to the power of 4 times 5, and now I'm going to replace u back in. So cosine of 2x to the power of 4 all to the power of 4. Again, I suggest leaving that. If you wanted to, you could always multiply the 5 times the negative 8, and so we would have a negative 40 out there, but you don't have to if you don't want to. Alrighty, it looks like this problem is all about chain rule. So we have the inside here is going to be x squared plus 4x, and the outside is going to be inverse sine. So let's go ahead and set that up. So here we get u prime is equal to 2x plus 4, and here g prime of u is equal to the derivative of inverse sine, and that is going to be 1 over, and we take the square root of 1 minus u squared. So here we're going to go ahead and multiply those together, so I get f prime of x is equal to, and we take that 2x plus 4, and we multiply it by 1 over the square root. And let's go ahead and replace u back in. So I get x squared plus 4x quantity squared. Another way we always remember it is we have the derivative of the inside in the numerator. And then in the denominator, we have 1 minus the inside squared. So you can do that either way. You can either go straight to this step if you remember it, or you can always just set up chain rule. Either are totally correct. We're just finding the derivative. Alrighty, implicit differentiation, everybody's favorite. So remember, we're trying to find dy dx, or we can write that as y prime. Either is going to be totally correct. It just depends on what you prefer. So when we do implicit differentiation, we take the derivative of both sides in terms of x. And I know to do that because we're finding dy dx, where that dx is in the denominator. Alrighty, let's go ahead and do these derivatives. So the derivative of x cubed is just going to be 3x squared plus, and now we want to take the derivative of 2y squared. So what we're going to do is kind of like chain rule. We're going to do a normal power rule. So I bring that 2 down, and I get 2 times 2 is 4, y to the power of 1, but I don't need to write that. But here's our issue. We can't take the derivative of y in terms of x. So if I could do that, I would just leave it as 4y. But since they're different variables, I have to multiply by the derivative of the inside. So the inside in this case is just going to be the variable y. And the derivative of y in terms of x, well, that's our y prime. So we're actually secretly using chain rule even for the x. The inside is x, and the outside is the power of 3. But when we take the derivative of x in terms of x, it's just 1. And we don't need to write times 1. So now let's go ahead and take the derivative of 5. We know the derivative of a constant is just going to be 0. So we are trying to go ahead and solve for this y prime. So I want to get this all by itself. I'm going to move over that 3x squared. So I get 4y times y prime is equal to negative 3x squared. And now in order to get y prime by itself, I'll divide both sides by 4y. And that is our solution. So let's go ahead and do that again over here. We have xy equals e to the power of y, and we're going to take the derivative of both sides in terms of x. So on this left side, we are going to have to use product rule because we have a product of two variables. So let me go ahead and set that up. So the derivative of x in terms of x is just going to be 1. But the derivative of y in terms of x is just going to be y prime, the first derivative of y. So let's go ahead and set up that product rule. We're going to multiply across and add them together. Alrighty, so now we want to go ahead and take the derivative of e to the y. So remember, with our e rule, we can write it as a triangle. So first we drop it down. It's totally the same. But we have to multiply it by the derivative of the exponent. So that's going to be y prime. Alrighty, so let's take a moment to pause and let's look for our y primes. It looks like we have 2 of them here, and so what I want to do is make sure they're all on the same side. So I'm going to go ahead and subtract that xy prime over. So now I have the y primes all on one side. I want to go ahead and factor it out. So when I do that, I get y prime times, and now I have the leftovers e to the y minus x. And so the purpose of moving it to one side is so we can factor it out and divide over those leftovers. So when I divide them over, I get y divided by e to the y minus x is equal to our y prime. And this is our final solution. We got y prime all by itself. Alrighty, so now we're going to look at logarithmic differentiation in order to find dy dx or y prime, whichever one you prefer. So I didn't make a video on this. If you guys would like me to make a video, just let me know in the comments. But what we do is we take the natural log of both sides. The purpose of this is that we can use exponent rule with natural logs. And so the exponent comes to the front and it's multiplied. So this becomes natural log of y is equal to x squared times the natural log of x. So now that we have this simplified a little bit, we can go ahead and take the derivative of both sides. So here on this left side, when we take the derivative of natural log of y, I know this becomes 1 over y, but remember we have to multiply this by y prime. And now we have to set up product rule because we have x squared multiplied by the natural log of x. Notice here we do have multiple x's, and that's how I knew we have to use product rule. So let me go ahead and set that up. Okay, let's find these derivatives. So the derivative of x squared is just going to be 2x, and the derivative of the natural log of x is going to be 1 over x. So remember, we need to cross multiply these and add them together. Alrighty, so we actually can go ahead and simplify this right here. X squared times 1 over x is just equal to x. So I'm going to go ahead and rewrite that. So now what I want to do is I want to get y prime all by itself. So what I'm going to do is multiply both sides by y in order to get this guy to go away. Okay, we are almost done. There's one last step, and it's that we want this whole thing to be totally in terms of x. So notice here we do have a y, and we can replace that with what y was originally equal to. And so here I have y prime equals, and everything inside remains the same because they're all in terms of x already. But now instead of y on the outside, we have x times x squared, blah, blah, blah. I said that wrong, but it's fine. And this is actually going to be our final solution. Alrighty, we have one more problem here. Let's go ahead and look at it. We have two runners start moving at the same point. One runs south at 8 miles per hour and the other runs west at 6 miles per hour. At what rate is the distance between the runners increasing 2 hours later? First, I'm going to go ahead and set up a diagram. Alrighty, so I have a drawing set up here, and we have that it's moving south at 8 and west at 6. So first, let's go ahead and talk about what this means graphically. So you can think of this as an x and y graph if you wanted to. We have one person is moving to the left at 6 miles per hour, and we have one person is moving down at 8 miles per hour, right? And so if we think of this as x and y, I know this is the x-axis and this is the y-axis. And so this is like telling me the rate of change in terms of x and in terms of y. And remember, this is going to be over time because we live in terms of time, right? So this tells me actually that I'm going to have the derivative of y in terms of time is going to be 8. And we also have that the derivative of x in terms of time is going to be 6. Another way you can think about this is if you like the primes, we have y prime is equal to 8 and we have x prime is equal to 6. So you can think about it either way. So now let's go ahead and talk about the moment of interest, and that's the rate that the distance is increasing 2 hours later. So let's go ahead and draw a diagram for 2 hours. So I know at 2 hours, I'm going to know the distance that they've traveled only because I know how fast they're traveling per hour. So the first runner that's moving west is moving 6 miles per hour. So at 2 hours, it's going to have gone 12 miles. And then the same thing for the one going south, they're going to have gone 16 miles. So we have at the moment of interest that x is equal to 12 and that y is equal to 16. So let's go ahead and talk about what is the distance in between them. So say this is d. And we can actually go ahead and find the distance using the Pythagorean theorem. We have distance squared is equal to 12 squared plus 16 squared. And so now I have that the distance between them, so I'm going to just label that D, is equal to 20. And so this is going to be 20 miles. So we're going to go ahead and use this in order to calculate the rate that the distance is changing at 2 hours. So if I wrote this in general, we're going to have a general triangle just like this. And so the equation for this triangle is going to be x squared plus y squared equals the distance squared. But remember, we're going to take the derivative of this all in terms of time. And so when I do that, when I take the derivative of x squared, this is going to be 2x times the derivative of x, or x prime, plus 2y times the derivative of y, and this is equal to 2 distant times the derivative of distance. And remember, we're trying to find this guy right here. And we can now go ahead and plug in all this information that we know. So we found that x at the moment of interest was equal to 12, right? And that's written right up here. So we can go ahead and plug that in. So I get 12. And also x prime was the rate at which we were running, which was found right here. And so we can plug that in as 6. So now we do the same thing with our y's. We got y was equal to 16 and y prime was equal to 8. And then distance was what we already saw for, and we got that to be this value of 20 over here. Alrighty, so let's go ahead and simplify this. First, we have 2 times 12 is 24 times 6. 16 times 2 is 32, and that's multiplied by 8. And this is equal to 40 times d prime. Don't be afraid to whip out that old-fashioned math. So here we can do 24 times 6, and we get 4, raise up that 2. 6 times 2 is 12, plus 2 is 144. So here we get 144. And now we can do 32 times 8. So 8 times 2 is equal to 16. Add that 1. 8 times 3 is 24, plus that 25. So 256, and this is equal to 40 times d prime. And again, we can whip out the old-fashioned math and we can just add those together. And we get a value of 400, which is equal to 40 times d prime. We divide both sides by that 40, and we get that the distance is equal to 10. And so we can go ahead and highlight that. Some professors do want this written out nicely, so let me go ahead and make some space. So if I were to write this out nicely, we would have, and there we have our solution. So again, like I said, some professors are fine with just boxing, yeah, the distance, the rate of change of the distance is equal to 10, or they want you to write it out all nicely. So it depends on your professor. It might be safe just to do both. But that is all we have for the exam. We scored 100 out of 100, proud of us. If you enjoyed this video, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, if you enjoyed this video, please leave a thumbs up and comment other topics or problems you'd like to see done. Thanks for watching.